Velkommen her til det her webinar, som Vækse holder angående DC-kontaktorer. DC-kontaktorer er jo ikke noget nyt. Det er jo noget, der har været der i mange, mange år, og det vil vi høre lidt om lige om lidt her fra Schaltbau af. Men man kan sige, at det er lidt nyt i øjeblikket, da der kommer flere og flere applikationer med DC, der vi ser nu, med at det tager indpas nu her i de forskellige områder. Så very warm welcome to you.
Thank you.
Emmanuel.
Thank you for receiving me.
So, and I hope you can give us some, we have only half an hour, so I know it will go a little bit fast here, but, and if you have any questions, so please use the chat and maybe we will take that after the meeting here. So, can you tell a little bit about where you come from and what is the behind the company for the DC contactors?
Yeah. So, I'm representing Schaltbau GmbH, a German company, founded in 1929, specialized in DC current. So we have a long history in rail application, and since the last decade, we noticed a strong development, a strong demand in terms of power for industry. And then we decided to offer the technology used in railway to the industry. So for this, we decided to create a new brand named ADC with a high focus on industrial products, still keeping in mind the story of the experience of the rail components.
So it's a more or less a new area. So you take all the good benefits and the technology from the area you have been in many years to more in the industrial area.
Yes, exactly.
Yeah.
So we noticed that there are different activities, different sectors, and different competitors. Competitors coming from different areas. We come from the power electronics on rail, specialized in DC, as I explained, and we meet also some competitor coming from the industry market, and generally these competitors are familiar with AC technology. And they make some derating on their products in order to comply with the requirements of DC.
Yes.
On the other hand, we also noticed in the last decade that some competitors come from more the extra low voltage area, the electronic, mainly electronic, and the low power was sufficient, but now with the increasing demand of power, they are facing technological issues, which are for us not an issue because we come from a railway standard where you have voltage up to 3 kilovolt and current up to thousands of ampere. So so we have good experience in this.
So this is not new for you, but we see more and more application is new for that actually. Yeah. Okay. Yeah.
Also to explain about the rail, because of course we tried to introduce the product we had originally 10 years ago, and the rail business is very specific because you have small volumes and very high demand in terms of documentation, also in reliability, all these aspects. And you have high inductive loads and things like that, and which are not really required for the industry. So we had also to adapt our product to face the demand with bigger volume and more attractive prices, of course.
Yeah. Okay. Can you very short give because today it's a DC contactor, but can you very short see what you actually the different area you worked in a very short version, and then we go back to the DC.
Okay. No problem. Yeah. So in terms of product, Schaltbau experience is so we are a manufacturer of electromechanical components. So of course we make contactors. We will come back to this later on. But we also manufacture connectors for industry and railway, and also snap action switches for high demanding quality and when the life of the people is threatened. So you can find our micro switches generally in train master controllers to check the status of the doors of a train, on platform screen doors also in railway stations to avoid the people falling on the track. And in the industry area, or more global area, you can see them in elevators or cranes. So, and also we have some material for some electronics for rolling stock, very, very specialized, but I think it's not really the subject.
No, we have to continue for the DC contact. Yeah. I think this is the topic today. Yeah.
So now, since a decade, as I said, there is an increasing demand of power in terms of voltage and current. And so now we address the new market we decided to address with the brand ADC, mainly focus on EV charging system, energy storage, data center, power conversion, test benches, and also DC microgrids. So here you really have a lot of DC. We also have a focus on the e-mobility, which is something of concern today. And there you can find different kind of applications, of course, in automotive, but also in commercial vehicles, intralogistics. So here we are there since many, many years. EV duty vehicles for mining trucks and things like that. We also have some interesting contactors which are DNV certified, so we can focus on the marine. We also have some focus on aviation and also special vehicles.
Okay, so if you go in this segment, then where do you make the difference? So,
in terms of products, so I explained we come from a different area we come from the power electronics, and so we have a huge experience from that. And compared to the people coming from the electronics, so to speak, we generally face competitors making encapsulated contactors. So they have a gas and they try to extinguish the arc by putting it under pressure. Okay. The way we deal with it is completely different. We use the railway technology. So our experience from railway, where our philosophy is really to handle the arc, to let him express himself. So we want him to express itself, but the way we want. So we let the arc exist. Uh-huh. We stretchen the arc so it will get longer, cooler, and weaker. So for that, to send it in the right area of the contactor, we generate an electromagnetic field, and we send the arc in the right direction to splitter plates, so that the arc will divide himself, and will extinguish naturally, and will exhaust through the vents that you can see on the side of the video, of the picture. So one interesting thing with the permanent magnets is that, of course, as mentioned, this contactor and all our contactors are built on the same way. They are almost all bidirectional. So it means that whatever the direction of the current, you can plug the contactor in a way or another. It doesn't play any role. It doesn't matter. The current will always be treated in the proper way. The arc will be treated in the proper way. So the fact is, with the permanent magnet, the magnetic field is always in the same direction. So this could be, and we handle it in a way that the magnets are set in a special way that you don't need to have a coil to generate the magnetic field. And this gives us a strong support in terms of energy saving.
Yeah.
Because we don't have the minimum, the critical current. You see some vents also, so we don't have any gas inside, so the pressure inside and outside the contactor is the same.
Okay.
So
no explosion.
So there is no risk of explosion compared with encapsulated gas, because there is no warming, or the warming can go out through the vents, and the cooling can come from the vents. So this is roughly what happens inside. It could take hours to explain.
Yeah, but we have to. So, yeah.
Then another topic that comes from the rail is mentioned. We have AgSNO2, so silver synoxide contact tips. AgSNO2 is the most resistant metal piece that resists to arcing. So we have a better resistance in arcing. And then with this, we can ensure a very long time of switching, and also a good conductivity, which means that you have a lower resistance and less power dissipation of the contactor. So less power dissipation means also that the energy that is going through the contact, you have less loss. And so you can, when you sell, for example, the energy through a charging station, you sell more energy to your customer than the less you dissipate.
Yeah.
So this is an interest for the cost.
But here I think also we talk about a longer lifetime, because the mechanical is a better function there. Yeah.
Yes.
Yeah. Okay. Yeah.
On another topic that we get from the rail is the auxiliary contact. Is a real mechanical contact where you get a real status of your contact. So it's a mechanically linked contact of the auxiliary contact to the main contact. So for that, you are always sure that the status you will get on your auxiliary contact is reflecting the reality of your contact. And this, unfortunately, is not always the case in some competitors.
Yeah.
So this is a high focus to have to check.
To be safe there.
Yes,
to
be safe.
Yeah, great.
Then another important device of the contactor is the coil itself, because this is the one that generates the movement and that will open or close the contact. So in order to handle the arc efficiently, we need a really strong spring in order to open quickly. And a really strong spring means that you need a strong counterforce, so a strong coil to strike against the spring. And when you have a strong coil, it means you need a lot of energy. So what we do, we have some standard coils that are made for specific applications, but we have generally we have a coil economizer, what we call coil economizer, which is a PWM system that allows the contactor to have a high high power in the beginning in order to establish the contact. And then it releases the power consumption. You don't need more strength when the contact is made. So just the holding current is getting lower.
Okay.
So you save, you can save there some energy because you can ensure that you always have the right energy to maintain the contactor closed. Also in the electronic, we have a lot of checking about the temperature and many devices that allows us, in case there is a warming that would generate a small release of the contact, then you will the small release of the contact. Sorry.
Okay.
Then it will give some more strength at one point, so that you get more pressure when it's only when it's required.
When it's needed.
Yes.
So you are sure it always is on the contact is with the
right pressure,
yeah.
And so you have a very low consumption, low resistance, and low consumption.
Yeah. Okay.
So here on this kind of contactors, we can really reduce the power consumption.
Yeah.
So we have a high focus on our contactors in order to really optimize the consumption and to reduce the losses either on the main contact or on the coil consumption.
Okay. And I think that is very important. In the past, when we talk about 2 amp or something, it doesn't matter. But now we talk about 2,000 amp or 800 amps.
Yeah.
Then it's very important to have the right connection there. I think.
Yes.
Yeah.
And also with high voltage, you need to make sure that the arc handling will be well handled. Because when you are in extra low voltage, it's not really a big deal because the arc will not show up. But when you talk about low voltage, so I mean between 50 and 1500 volt, or 120, sorry, because in DC it starts, the limit is starting at 120 volts. Then here you really need to take care about the arc handling.
Yeah.
So, and even micro arcing.
And this is also surprise somebody because low voltage actually is up to 1,500 volts.
Yes.
Yeah. So it's a little bit heavy actually.
Yeah. So, in DC, and then after you have high voltage after the 1,500 volt. Yeah.
Okay. Yeah.
So we have a summarize about the difference between the open system that we offer compared with encapsulated systems.
Yeah.
So of course, in our system there is no risk of leakage because as we could see previously, there are vents on the side of the contactor. And the pressure inside and outside the contactor is exactly the same, whatever the phenomena, the heat that is coming out from the contactor is happening. Because an arc is around 20,000 Kelvin. Okay. So it's very warm. It's not for a long time, but it's getting very warm. And when you are in an enclosure, it can generate some troubles.
Yeah.
Also, the problem you have is in some competitors' encapsulated contactors, you have hydrogen. So it's a high volume of hydrogen. So the concentration is very high, so there is no risk of explosion. But you shall also make sure that the level of hydrogen remains to a certain level. When you reach 40% of hydrogen, then it's highly flammable or explosive. So then it starts being critical.
Yeah.
So we talk about the heating up, of course. As the air can go through the contactor, we have natural cooling. In the encapsulated system, when you close many times in a row, you don't have the time to cool down. So this can generate also some trouble.
So this is a good benefit and very important if you have a contactor where you have to switch a lot of times actually.
Yes.
Yeah.
Yes.
At the construction is the fit for this application. Yeah.
Yes.
Yeah.
Yes. Also on the connection, we have to make sure also to differentiate when you make opening under load or not, because there are some products that are, you will define the right product depending on the load you wish to break and you wish to break or not. So then there is the overpressure, of course, so it's due to heating, because when you heat up in enclosure, the air the volume of air increases. So, and if it's encapsulated, then the pressure rises. Mm-hmm. Not with our products. And then we have also the contact material. So I talked about the silver synoxide earlier. Most of the competition contactor, they just make direct copper connection. And the problem is that the welding point of the copper is much lower than the silver synoxide.
Yeah.
So you have more chance, or you have less chance with our product to have a welded contact in your system. So you gain in terms of operation.
Yeah.
Yeah. So in terms of product range, here we see a bit the portfolio in terms of contactor for ADC, for the industrial market. So if we go from the right to the left, let's go in another way for this time. You have the AFS, you can see on the right, which is mainly for extra low voltage. So we discussed, you see, 48 to 80 volt. This is extra low voltage. This is typically what you can find in forklift or small trucks. It's very low voltage. So here, there is not so big risk of spark and arcing.
Okay.
Then when you come to the range of low voltage, you see the C310, C303, C300, C320. We go up to 1,000, 1,500 volts, and from 150 to 1,000 ampere. So here we start to have some volumes. And these products are mainly dedicated for resistive loads. So which is what you need generally for charging stations, for BESS or this kind of application.
Yeah.
When you have higher loads, inductive loads, then we have also the CP contactor, which are a bit bigger, and it can even go on the high voltage, because you can see we reach 3,000 volt in nominal voltage, and we can reach also some thermal current of 2,000 amp. Yeah. So it can go really high. And sometimes you can even go above on the complete range, depending on the cooling strategy we put in place within your system.
Yeah. Okay. So this is only a small, you can say, a few pictures of what you can supply of different ways. So it's important to have to know also if it's a resistance or it's a capacity, or is it the inductive load you have actually. That's really important to know how you. Which choice you will take for that.
The application, the customer application is crucial.
Yeah.
Because if you don't know the application, if you don't have the input data, you can't really make your choice between a contactor that is big, like a suitcase and weighing 15 to 20 kilograms, and a contactor with, on the paper, the same performances, but which is big as half a liter of milk.
Yeah.
So, and which weighs 500 grams. So you could see 1500 volt and 500 amp on both products, but one will resist much more in terms of inductive loads, many more cycles under load, breaking under load, while the other can't do that, but maybe the application doesn't need that.
Yeah.
So the application is crucial.
So can you show some application highlights?
Yeah. Yeah, we have. So just to remind, in the application where our products are interesting due to the robustness of the design, and we have no chance of contact or less chance of contact welding. We have the contactors, which are an asset on our product, and this comes from the railway history. We are fully bidirectional, and this is very useful when you want to make a vehicle to grid or whatever to grid or vehicle to whatever.
Yeah.
And also we have the mirror contact function, which is also very appreciated because it gives the real status of the contact of the contactor. So some applications, of course, you can find our contactors in EV charging station. So we mentioned. So in the range, you can see we have some ADC products, C303 up to C320. So we go from maybe 150, 350 amp to 1,000 amp, and sometimes even higher. You have to see with the customer the strategy he wants to put in place in order to ramp up in terms of current. So we have some application deck. We will go quickly over it because it's just when you need some details. This is something to support a discussion with the customer. Yeah. It can be quite useful. So here you have an example for EV charging. You can find our product also for e-mobility. So it's almost the same range of product from up to 1,000 amp for 1,500 volt. Or mainly for resistive and capacitive load. Same the application deck. In marine application, you can find our product. As I explained, as I told earlier, we have some products that are DNV certified. So this is quite interesting for the customer.
So they have the approval for this
for marine application.
Yeah.
So this can be of interest for some customers. Still the application deck, if needed to go in detail. In the ESS also, battery energy storage systems. So here you see the range is a bit different. We go quite a bit higher. We go from the C300, that is from 500 amp, and we go up to the CP because sometimes you can have long wirings, and so it means chances of inductive loads. So in that case, you should prefer a CP when you need to break inductive loads. And of course, here we talk also about, because when we talk about BESS, we talk about energy in general, and we can find also our product in windmills, and also so we can find the contactors sometimes, but also the micro switches to adjust the pitch and all the blades orientation and the windmill orientation. So here we have some product that may be interesting for the customers. So and I think and of course there is also intralogistic, and here intralogistic. So we make the contactors. You have specific contactors. If you see the combi, is a very special contactor because you have it's an emergency stop and a contactor and a fuse holder, and it makes everything, and also a micro switch inside. So it's a multiple function apparatus. We have some extra low voltage contactors, normal contactors, and also LV plugs, which is the standard for intralogistic vehicles.
So what I hear also, you said in a different application, you really have designed some products special to some application.
Yeah, for some applications.
So it's very important if our customer have, if you have an application, you need a DC contactors, to contact us and hear what is actually your application, because maybe there can be some benefits for you to have a special one that is special designed for this segment area.
Yeah.
Okay, so I think that's the time is we are very 6 seconds after. So thank you for the listens. If you have any questions, you are very welcome to use the chat. You are also welcome to call us, I hope, and we can help with the application. So thank you, Emmanuel.
Thank you, Lars.
Thank you, and hope we will stay here a little bit more.
Yes.
Vi bliver her lige et øjeblik, så hvis der er nogle spørgsmål på chatten, så er I meget velkommen til at skrive på den. Så kan vi håbe, vi kan svare på spørgsmålet.